The question is like this: using the properties of determinants and without expanding, prove that the determinant b plus c, q plus r, y plus z and so on is equal to 2 times the determinant apx, bqy, crz. Okay. Now to solve this question, first of all, I take the left hand side, right? So in left hand side, I have been given this determinant b plus c, q plus r, y plus z, c plus a, r plus p, z plus x, a plus b, p plus q, x plus y, and we have to prove that this is equal to twice apx, bqy, crz. Okay. Now to solve this question, first of all, what I see here is this, that if I add all the elements which are there in column 1, column 2 and column 3, I can get this 2 as common from the determinant. Okay, so adding all the elements in C1, that is b plus c, c plus a plus b, you can see here exactly what I have written here, are there in the column C1, is equal to twice a plus b plus c. Okay, a plus a 2a, b plus b 2b, c plus c 2c. So taking 2 as common, I am going to get twice a plus b plus c. So it is very crystal clear. Okay. Similarly, adding all the elements in C2, I am going to get q plus r, r plus p, p plus q as equal to twice p plus q plus r, and adding all the elements in C3, I am going to get y plus z, z plus x, x plus y, okay, as equal to twice x plus y plus z. So, to get 2 as common, what I am going to do, I am going to apply R1 is changed to R1 plus R2 plus R3. Okay, that is to the element, to the row R1. I am going to add the elements of R2 and R3. Okay, so I am going to get this as twice a plus b plus c, twice p plus q plus r, twice x plus y plus z, and the remaining determinant remains the same. Okay, so when we apply this operation, R1 is changed to R1 plus R2 plus R3. You can see here to b plus c, c plus a and a plus b are added, to q plus r, r plus p and p plus q are added, and to y plus z, z plus x and x plus y are added. So we are going to obtain these terms, these values only. Okay. So because now you can see here, because 2 is the common factor in the first row, that is R1. So we can take 2 as common from R1. So taking 2 common from R1, I am going to get this 2 times a plus b plus c, p plus q plus r, x plus y plus z and so on. Okay. So further what I am going to do, I am going to subtract the elements of row 1 from the second row. Okay, so applying R1 is changed to R1 minus R2. So I am going to get this as 2 times a plus b plus c minus c plus a, p plus q plus r minus r plus b, x plus y plus z minus z plus x. So you can see this c and c, a and a are going to cancel out. This r and p are going to cancel out, and z and z and x are going to cancel out. So I am going to get this as equal to 2 times bqy, c plus z, r plus p, z plus x, a plus b, p plus q, x plus y. So till now you can see that I got a row exactly the same which I have to prove here. So I'm converting this determinant into this determinant in step by step. Okay. Again applying R3 is changed to R3 minus R1. R3 is subtracted from the R1. Okay. So a plus b minus b, p plus q minus q, x plus y minus y. So I'm going to get this. Okay, so this b, b, q, q and y, y are going to cancel out. So I'm going to get this as twice b, q, y, c plus a, r plus b, z plus x, a, p, x. Okay. Further applying R2 is changed to R2 minus R3. Okay, from the second row I'm going to subtract the elements of the third row. So I'm going to get this as c plus a minus a, r plus b minus b, z plus x minus x, and remaining part of the determinant is exactly the same. Okay, so this is going to be equal to twice b q y c r z a p x. Okay, so now till now you can see here is that we obtain this row bqy, which is there to be proven, crz, which is also there to be proven, and apx, which is there to be proven, but the order are different. So here we have to, in proving this, apx is the first row and here it is the third row. Okay, so we have to just interchange the order of the rows to prove the question. Okay. So, taking the determinant and applying R2 is interchanged to R3. So, first of all, I am going to interchange the row R2 and R3. So, whenever we interchange two rows, the elements of two rows, then the determinant multiply with a minus sign. Okay, so this will be equal to 2 times minus 1, and here APX, that is the elements of the third row, are going to be written in the place of second row, and the elements of the second row are written in the place of the third row. Okay, so we have interchanged the elements of the second and the third row. Okay, now you can see that we have obtained the third row exactly the same which we are required in the proving. Okay, further applying R1 is interchanged with R2. So this is the row R1 and this is the row R2. So we are going to interchange the rows. So on interchanging the row, what is going to happen? This determinant, this whole value is going to multiply with minus 1 again. So I'm going to get minus 1 square. Okay, and these two rows are going to interchange. So I'm going to write the second row in the place of the first row, and the first row I'm going to write in the place of the second row. So I'm going to get this, and after applying this, what I get is that the order of the rows are exactly what I am to obtain in the proving. Okay, and minus 1 square is equal to again 1. So this is equal to twice APX BQY CRZ, which is equal to the right hand side, and hence the question is proved.